Hi, fifth grade. Today we're going to be doing Module 2, Lesson 11. And for this lesson, we are going to continue multiplying with decimals, except now our decimals are going to be going into the hundredths place. So last lesson we had decimals that went into the tenths, but now we have decimals going into the hundredths. So this lesson is going to be very similar. We're just going to have more digits we need to work with. So let's go ahead and get started. For this lesson and in the problem set especially, you're going to see a lot of these little thought bubbles. And these thought bubbles are going to remind us that we need to take this decimal and we need to rethink it in unit form to help us when we write it in expanded form on our area model. So I know there's a lot of words being thrown around right here, but let's take a look at what this means. So when I look at the number 7 and 38 hundredths, what I can do is I can kind of imagine that that decimal is not there. And when that decimal is not there, what I can do is I can kind of see that this number looks like 738. So I'm going to write 738, and then the units are hundredths because that is the smallest place value I have in this number because this 8 is in the hundredths place. So I have 738 hundredths. So in my area model, I can write the unit hundredths right here, just to remind myself that this number I'm about to write in expanded form at the top is supposed to be hundredths. So let's write 738 in expanded form. So if I were to pretend that this decimal isn't here, the 7 looks like it would be in the hundredths place. So I have 7 hundreds right now, plus I have 3, that kind of looks like it would be in my tens place, so I have 3 tens, so that would be 30, plus I have 8, and if I were to pretend that decimal wasn't there, that 8 looks like it would be in the ones place, so I have 8 ones. So I have 700 plus 30 plus 8, so 738 hundredths. Then I need to draw those lines straight down where my plus signs are at, and then I can start writing the expanded form of my other factor. So remember, starting with the smallest place value, I have 1 plus 4 tens, which is 40. Draw that line straight across, and then I can start multiplying. So let's start with our first row. We have 700 times 1, which is just 700. I have 1 times 30, which is 30. And I have 1 times 8, which is 8, which leaves me with 738 hundredths for my first partial product. Now for my next partial product, I'm going to multiply 700 times 40. 7 times 4 gives me 28. And then I add 1, 2, 3 zeros. Make sure you're always adding all the zeros. And then we have 30 times 40, 3 times 4 is 12, and then I have 2 zeros I need to add. And then 40 times 8, 4 times 8 is 32, and then I add that 0. Now I need to add all of these factors, or all these kind of partial products together to create my next partial products. And I can set up a standard algorithm to help me out with this since these numbers are a little bit bigger. So I add them up, and they give me my next partial product of 29,520. So now what I need to do is I need to add this partial product, 738, and this partial product, 29,520 together. Remember, these are all hundredths. So 738 hundredths, 29,520 hundredths. Then I am going to set up this problem right here, like so. And then we can start adding these together for our final answer. 0 plus 8 is 8. 2 plus 3 is 5. 5 plus 7 is 12, so I carry the 1, leave the 2. 1 plus 9 is 10, so again I'll carry that 1, leave the 0. And 1 plus 2 is 3. Which gives me a final answer of 30,258 hundredths, because remember, this is all still in unit form. So what I'm going to do when I go to write my final answers, I can still write these digits up here, but I need to make sure that I write my answer in standard form now. And standard form means that I have the decimal in my answer. So to do this, I'm going to think about where is my hundredths place. So this very last digit would have to be my hundredths place, which means that this 5 would be in my tenths place, which means that I need a decimal right here because where my tenths place is at, right after that is my ones place, and in between these two, there needs to be a decimal, which gives me my final answer of 302 and 58 hundredths. So let's check this in a standard algorithm, and this is going to be very similar to what you saw in the last lesson. So we're going to write 738 hundredths just like this, just like the last lesson, and then we'll multiply it by the other factor, 41. 1 times 8 is 8, 1 times 3 is 3, 1 times 7 is 7 for 738 hundredths, just like our area model. Then I need to add a 0 for my placeholder. I do 4 times 8, which is 32, 4 times 3, which is 12, and 12 plus 3, which is 15, so I carry the 1, leave the 5. Then I do 4 times 7, which is 28, and then 28 plus 1 is 29. Again, for my second partial product of 29,520. I'll go ahead and add up all of these numbers. 8 plus 0 is 8. 3 plus 2 is 5. 7 plus 5 is 12. 1 plus 9 is 10. And 1 plus 2 is 3. Again, remember, this is 30,258 hundredths. So I need to make sure that I put my decimal in the right spots, which would be right here if I were to write it as a decimal and not in unit form. So that is how we do these kinds of problems. Again, very similar to the previous lesson, just we're working with more digits. So let's take a look at our next problem. And our next problem is 8 and 26 hundredths times 128. So again, just more digits that we are working with. So we get all of this erased. And this problem looks like this. So 8 and 26 hundredths times 128. Again, I need to rethink what I am seeing right here, this decimal and standard form, and I want to think of this decomposed down to the hundredths place. So basically, I'm going to think of this number without this decimal, and I'm going to think about, what does this number look like? Well, it looks like 826. So at the top of my area model, what I'm going to do is I'm going to write what 826 would look like in expanded form. So if I were to pretend that this decimal is in here, this 8 would look like it's in the hundreds place. So I would have 8 hundreds plus this 2 would look like it's in the tens place. So I have 2 tens plus, and then my last place value, if this decimal wasn't here, this 6 would look like it's in the ones place. So I'll do 6 ones. Now remember, this is all in unit form, so I have to write the unit hundredths. And the reason I got this unit hundredths is because this 6, this very last place value, is in the hundredths place. Now I'm going to create the rest of my area model. So wherever I see those plus signs, I draw those lines straight down. And then I have this number 128, which I also have to write in expanded form. So starting with my smallest place value, my ones place, I have 8 ones plus 2 tens, so 20 plus 1 hundredths. And again, wherever I see those plus signs, I need to draw a line straight across. And now I can start multiplying and then adding up to get my partial products. So we're going to start with 8 times 800. 8 times 8 is 64, and then I add on these 2 zeros right here, so for 6,400. Then we have 8 times 20. 8 times 2 is 16, plus a 0, which is 160. And finally, we have 8 times 6, which is 48. I will add up these 3 numbers together to get my partial product. And 0 plus 0 plus 8 is 8, 6 plus 4 is 10, 1 plus 4 is 5, 5 plus 1 is 6, and then 6 plus nothing is 6. So my first partial product is going to be 6,608 hundredths. Then I need to find my second partial product. So for my second partial product, We're going to do 20 times 800, so 2 times 8 is 16, but now I have to add 1, 2, 3 zeros. So I add on those 3 zeros for 16,000. Then I do 20 times 20. 2 times 2 is 4. And I add on these 2 zeros for 400. And then 20 times 6 gives me 120. And now I need to add all of this together. For this problem, I'm actually going to do this in my head. So I have 16,520 for my next partial product. So this is my first partial product, and this is my second partial product. Now I'm going to move on to my last row, and for this one I have 100 times 800. 1 times 8 is 8, and then I have 1, 2, 3, 4 zeros to add for 80,000. Then I have 100 times 20. 1 times 2 is 2, and then I have 1, 2, 3 zeros for 2,000. And then 100 times 6 is 600. For this one, I'm also going to do this problem in my head. I'm lining up those place values in my head. If you need to, you can set these up in a standard algorithm to add them up as well. So I am going to have a 2,600 as my third and final partial products. Now I need to add all these partial products together to get my final answer. So I have a 2,600 plus 16,520 plus 6,608. So we'll add all of these up. 0 plus 0 plus 8 is 8. 0 plus 2 plus 0 is 2. 6 plus 5 plus 6. Remember, this is one of those problems where I can kind of split up the facts that I know. So I can do 6 plus 6, which is 12. And 12 plus 5 is 17. Carry the 1. Leave the 7. Then for this problem, again, I could do that 6 plus 6, which is 12. And then 12 plus 3 is 15. Carry the 1. Leave the 5. And then 8 plus 2 would give me 10. And remember, this is all in unit form still, so I have 105,728 hundredths. So when I go to write my final answer, I can write all these digits down just like I did before, but then I need to make sure I put my decimal in this number. So what that means is that this last 8 needs to be in the hundredths place, which means that this 2 is in the tenths, which means that I put a decimal right here because in between my ones and my tenths place, there should be a decimal for a final answer of 1,057 and 28 hundredths. So just like last time, we're going to check out this problem using the standard algorithm. I'm just going to erase some stuff so I have some more space. And let's get started. So we're going to have 826 hundredths. And then we're going to multiply this by 128. So for this problem, I will have 3 partial products just like my area model. I do 6 times 8, which is 48. Carry the 4, leave the 8. 2 times 8 is 16, and 16 plus 4 is 20. So carry the 2, leave the 0. Then I do 8 times 8, which is 64, and 64 plus 2 is 66 for my first partial product of 6,608 hundredths, just like my area model. Then I add a 0 for that placeholder, and I'm going to move on to this 2 right here. I do 2 times 6, which is 12. Carry the 1, leave the 2. 2 times 2 is 4. 4 plus 1 is 5. And then 2 times 8 is 16, which gives me a next partial product of 16,520. Just like my area model. And then I move on to my final partial product, and I need to make sure I add 2 zeros this time because I'm multiplying this number that's in a hundredths place. I do 1 times 6, which is 6, 1 times 2, which is 2, and then 1 times 8, which is 8, which gives me my next partial product of 82,600. I now need to add all this together to get my final answer. 8 plus 0 is 8. 0 plus 2 plus 0 is 2. 6 plus 6 is 12, and 12 plus 5 is 17. Carry the 1, leave the 7. 6 plus 6 is 12, and 12 plus 3 is 15. Carry the 1, leave the 5, and then 1 plus 1 plus 8 is 10, which again gives me my final answer of 105,728 hundredths. But of course, I need to make sure I write this number in standard form or as a decimal. And to do that, I need to make sure that this last digit is in the hundredths place for, again, that final answer, 1,057 and 28 hundredths. I know it becomes a lot of work to do these area models once you get so many partial products. So once you get to the problem sets, if you're finding difficulty with the area models, go ahead and just show me your work with the standard algorithm. This is the part that I really care about right now. So if this is starting to confuse you, I totally understand. Show me at least this part though. And if this helps you, great. Keep using it to help you out with matching up your partial products. You guys did a great job today, and I'm going to get you started on the problem set now. Have fun and good luck.